Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to do an electrolysis problem. Okay. Now, for an electrolysis problem to occur, we have to have a chemical reaction that does not like to occur. And the example that we have here is the copper chloride. Now, this is the same chemical reaction that we did in the demonstration in the previous video. So if you haven't checked that out, that'd probably be a good thing to check out. So the copper chloride forms copper that's solid and chlorine that's a gas. And when I do the oxidation reduction and calculate the cell potential, I get a negative cell potential, which means that this reaction does not like to occur. However, if I hook it up to a power source, just like I did in the demonstration in that previous video, we can force this chemical reaction to take place. And we use this chart to kind of figure out how much copper can be produced, okay, if I perform some electrolysis onto a solution of copper chloride. So here's the question. How many grams of copper can be produced with electrolysis when a current of 10 amps is applied for 1 hour? Okay, so I have the current, okay, which is 10 amps, okay, and I have the time, which is 1 hour. So if I have current and time, then I can calculate charge. And if I have charge, then I can calculate the moles of electrons. If I have moles of electrons, I can calculate moles of the substance, and then eventually 2 grams of that substance. And I'm going to use the conversion factors that I have in blue to move from one box to the other. Okay, so problem number 1, we're going to start on this side and work our way in this direction. And then problem number 2, we're going to start over here and we're going to work in the reverse order of what we're doing here in problem number 1. So problem number 1, we're starting here and we're going to end up here. So what I have is I have current and time. Okay, now amps, the 10 amps, just let you know, an amp is the same thing as a coulomb per second. Okay, so I want to put this 1 hour into seconds, and I'm going to use some dimensional analysis to do that. So I'm going to take 1 hour and I'm going to convert the hours into minutes and then the minutes into seconds. And there's 60 minutes an hour, 60 seconds in a minute, and this comes out to 3,600 seconds. Okay, now I'm going to use this time and this current in order to figure out charge, which is Q. So I is current, T is time, and I'm going to use those values to figure out Q. So if I do some cross multiplication, I find out that Q is going to be equal to the current times the time. So the current being 10 coulombs per second, 10 coulombs per second, times 3,600 seconds. You can see where the seconds are going to cancel out, and the Q is going to be equal to 36,000 coulombs, because 3,600 times 10 gives me 36,000. Okay, so right now I know that the charge is going to be 63,000 coulombs. And from here on out, all I'm going to do is some dimensional analysis with this 36,000 coulombs. So I'm going to put in the upper left-hand corner, and I'm going to change the coulombs, okay, into moles of electrons. Now I do that using Faraday's constant, and if you're in AP chemistry, this is on your AP equation sheet, so is the equation. If you're in college chemistry, this might be something that your professor asks you to memorize, or maybe they'll ask you to put it on an index card and you're allowed to bring that to class. So it's kind of dependent on your instructor, okay? But what Faraday's constant tells us is that we have 96,485 coulombs of charge for every 1 mole of electrons. So I'm just going to write that down. 96,485 coulombs of charge for every 1 mole of electrons. Okay. The next step is to go from moles of electrons to moles of the substance. So I'm going to go from moles of electrons to moles of the substance. Well, what substance? Well, the substance that I want to know is about copper. So I need to find a chemical equation that has moles of electrons to moles of copper. And that's going to be in these oxidation reduction reactions. Okay. Right here's my moles of copper, which is going to be 1. And here's my moles of electrons, which is going to be 2. So I'm using the coefficients in this reduction half reaction to go from moles of electrons to moles of copper. Copper has a coefficient of 1. The electrons have a coefficient of 2. It's a 1 to 2 ratio. Okay? And then finally, I'm going to go from moles of my substance to grams of the substance using molar mass. So moles of copper and 2 grams of copper. And I look at the periodic table and I find the molar mass of copper to be 63.5 grams per mole. So I'm just going to put this in my calculator, 36,000 divided by 96,485 divided by 2 times 63.5 will give me a value to 3 sig figs of 11.8 grams of copper. And that is going to be your answer. This is how much copper I can produce if I do electrolysis with 10 amps and I have it going for 1 hour. If you found this content helpful, please give it a like and subscribe. And when you add that comment, it really does push the information out to other students that might be interested in learning chemistry.